And we are live. Good. Okay, so we are doing geometry week 2. I'll do my usual preamble. It's very cold outside. It has snowed at least a foot in the past week or so, and I'm tired of it already. I want spring to get here. There's powder everywhere. It's pretty, but I can do without it. I was very cold when I went out with her just a few minutes so she could have a sniff around just a few minutes ago. This is Mocha. She's only here to say hi, and now I'm going to put her on the armchair and she's going to be good and be quiet for the whole hour. Down you go. Okay, lie down. Lie down. Stay. Okay, that should do it with her. And I'm wearing my Liverpool jersey, one of my Liverpool jerseys. Now let's get into the math. It's geometry. Geometry week 2. We are doing transformations. We're doing translation, reflection, rotation, dilation, and a couple of other things that are sort of overlapping with things that we were doing last week. So the first thing I want to do is talk about translation. Now, translation can be expressed in a couple of different ways. I'm expressing it one way right up here. This is sort of a notation that tells me the type of translation I want to do. And when you get used to the notation, you look at this and you realize immediately that someone wants you to do a translation. But I can also express that in the English language. I'm not going to do this example. I'm going to create an example. So let's say we start with, make sure that it'll all fit, x, y, and then we have the arrow. And what if we have x minus 3, y plus 3? I can translate that into English language. Now I'm using the word translate in two different ways. So the translation is the word for this type of slide that we're doing. A slide is a good word that's better describes what you're doing, but we have math words that go with it. And the math word is translate. So we are going to translate, we're going to do a translation of x, y, so that we change the x and the y in these ways. To say that in English, I will write the word translate, and I will say I'm going to the left by 3, because if x is having 3 subtracted from it, that means x is going in the negative direction, and that means left. So left 3, and then the y is having 3 added to it, and that means up. So up 3. Nearly ran out of room there. Good thing up is such a short word. So I can switch from this notation into the English language, the phrase that does the same thing, that describes the same thing, quite easily. And I can do it in both directions. I can switch from this English into that notation as well. We'll do that later. First, we're going to do a few examples where we switch from the notation into the English. My examples are written down right over here. Okay. How about x, y, arrow, and then I write x, y plus 7. So right away we get an answer to one of those what if questions. What if the x doesn't change? Well, then it looks like this. X will still be x. It's not going to the left, it's not going to the right, and we can see that by the notation. So therefore, when we want to switch into English, we're going to write the word translate. We need this to make sure that people understand what it is we're talking about. We're translating. And we're not going left or right, so we just don't even have to mention those. And we can go straight into the up-down thing, and it's going to be an up because the y is having 7 added to it. So I'll write up 7. So when you see up 7 with no instruction that says anything about left, right, you know that it's one of these where the x isn't changing. The shape is just moving up or down. It's not moving left or right. Let's do another one. X, y, and we're going to put our arrow, and this time we have x plus 5, y plus 3. Okay, we got y plus 3 again. That means I am translating, and I am going to the right by 5 because I'm adding to x. So right 5, lie down, stay, and then I am going up by 3. It's another plus, so I'm going up by 3. So up 3. Pretty easy to switch between the notation and English, isn't it? Let's just do a couple more examples, and then we'll switch on to doing something else. So I'm going to erase these top two. They're both done. And I'll leave this one there and I'll use it sort of as a model so that I can write up the next one. So I have xy, and I'm going to start writing this a little smaller because if I have long enough words, I'll slam into my grid lines. These are not fun to draw. I will talk about that. Okay, it sort of came into how I planned this week's lesson. So xy arrow, need more chalk. And this time it's going to be x minus 8. So now we have a minus with the x and y minus 2. Actually, we have minuses for both and we're subtracting for both of them. So how do I get that into English language? I write the word translate. And it's left by 8 because it's a subtraction. And it's down by 2 because it's a subtraction. I'll put a comma there. It was kind of jammed together because the words are getting longer when we don't have the word up. Okay, one more. Let's do one more. Let's do two more. We have xy. This one, I'm going to switch it up a bit. Arrow, x minus 3. Minus, I said minus, I didn't write a minus. X minus 3, y. So here we have this thing happening, and this time the x is changing, but the y isn't, so of course that can happen too. So we'll turn that into English. We have translate, and we are going to the left by 3 because it's subtraction, so I write left 3, and then I can stop because I'm not changing the y. So that one, I'm going to erase this one and do one more example, one last example. So erase this long one. Okay, and how about xy arrow, x plus 2, y plus 20. Okay, 20. Of course we can slide something up by 20 units. And when we get it into English, it's going to say translate right 2 and up 20. Yes, we're good at this. It was easy, I admit it, so I don't need any more examples. Y plus 20. Well, don't ask me to do that on this grid because y plus 20 would go way up into the ceiling, and that's one of the difficulties of trying to do something like this on the chalkboard. I'll tell you, I spent quite a time drawing this thing, and it's still not the most beautifully drawn grid that I've ever seen. It might look a little crooked. I don't know if that's the camera or if it's me, but it took a while, and I tried to make the x-axis and the y-axis more bold so that they show up better on the video. I don't know if I succeeded that much in doing that, and it just takes a really long time. Now we have this tool. I have my big teacher or chalkboard geometry tools, which are great, and then I have this one. I don't like this tool. Notice how I don't even have any chalk in it. So it has 5 places where you put a piece of chalk, and then you can draw at least 5 lines at once, which will be parallel and the same distance apart. It's useful. It would be useful if it worked. It doesn't work very well because I find no matter how much I fiddle with it to try to get the chalk into position, the chalks move and the lines don't draw well. You end up spending more time fussing with this thing than you would have spent if you just got a ruler and drew all these lines one by one. So I drew all these lines one by one, and I'm just going to do my best. Okay. Now, switching between the notation in English but in the other direction. So I'm going to put some examples down in English, and then we're going to switch them into this language. I don't want to erase all of it at once. So what I'm going to do is erase these bottom 2 examples, and I'll start writing and then I'll erase the top one afterwards. Where are all my examples? Now I want to start with English. So in this example I'm going to write here, I'm saying translate. I really have to write the word translate over and over again when I do this. It's really part of what we're doing, so I have to write it. Translate, my first one is going to be left 4, down 3. Left 4, down 3. It's hard to even make it fit. Now I'm going to erase this. And I'll put a couple more examples, but I don't want to do too many. It's taking so long just to write these. So, how about translate up 1? Translate up 1. So that's one of those what ifs, one of those different looking ones. This thing got kind of smudged when I was erasing before. And another one, translate I'll do right 9 up 4. Long just to write the question. Now, of course, answering the question isn't so long. We are doing x comma y with an arrow, and then in this first one that I'm doing this one first because it's on top, I'm only moving up. I am not moving left or right, so x is still going to be x, and that's how I show that. And then the y is going up by 1, so I'm going to write y plus 1. So that works, and it is quite easy, I admit it. Now here, translate left 4, down 3, x, y, arrow. Left 4 means x minus 4. Down 3 means y minus 3. Yes, this does go quite quickly. This one, translate right 9 up 4. X, y. Right 9 is x plus 9. And up 4 is y plus 4. So you see you have all these combinations of pluses and minuses and what size the number is. So you can make up lots and lots of examples of these very quickly. And then you want to make sure the students understand what the special ones look like this. So I think I'm just going to do one more. And what I'll do is I'll erase these two longer ones. And translate left 7. So it's another one of those ones where not everything changes. X, Y, arrow, make that look more like a Y. Left 7 means my X is having 7 subtracted from it, but the Y is not changing, so I just write a Y. So it's kind of like that one, but it's kind of like the opposite of that one. And that should be enough for these examples. Going back and forth between these two things, I'm looking at the time as well. Okay, so now I want to draw one. I'm not going to be able to draw too many, at least not with the grid. I can't do too many drawings with the grid because it's going to get messy really quickly. But we understand what this means, and I know the students are not seeing this for the first time. That helps too. So x plus 6 means that everything's going to the right by 6. But I have all this to draw. And it could be confusing if you're trying to take all of the bits of this triangle and think about how you're moving them to the right and down all at once. It gets jumbled in your head. So you need a strategy. And the strategy is pick one of the vertices and do that first. So I'm going to pick the top left vertex. And it has to go to the right by 6. So I'm counting squares. 1, 2, 3, 4, 5, 6. That brings me here, but I'm just putting a little dot here just as a placeholder because I'm not finished. The y is also changing. The y is going down by 2, so that means I'm going down from here by 2. 1, 2. So this is where I actually want that to be. Now the notation we use is if this triangle's vertices are A, B, and C, then what I just did was show where A is going to end up, and the notation we have for that is A prime. And then what's happening with the B? We could sort of figure it out because we have a good starting point with the A, but we can also just say, let's do this with all 3 vertices. So the B is going to the right by 6 and then down by 2. 1, 2, 3, 4, 5, 6 to the right, down 1, 2, and it's going to be right there. And yes, we could have figured that out, but I like having a method. And that's going to be my B prime. Very cluttered on this chalkboard wall right now. And the C to the right by 6, 1, 2, 3, 4, 5, 6, but down by 2, 1, 2. C ends up here actually touching the x-axis, and therefore we're going to have C prime. I don't know how well these primes are going to show on the video. And then I just have to connect the dots. And I get a pretty good copy. That's cool. So most of my strategies for doing all of these transformations involve connecting the dots at the end. I like to figure out where the vertices are going to go and be careful and get them there. And then you just connect the dots and it becomes a really easy little thing at the end. So that's fun. And now this is a big mess, and erasing it so that I can do another example is going to not be very much fun. I don't know if I want to do it at all. So what I'm going to do instead is I'm going to move on to the next type of transformation, because I know the slide to translate is the easiest one. So shouldn't spend too much time on it, no matter how much fun it is. The next one is the reflection. Now, the reflection in normal, descriptive words is a flip. When you take something and you flip it over, you make a reflection of it. So that's a nice descriptive word, but in math we call it a reflection. So I need to do some erasing. I will erase all of this. And I already did that translation, so although I'm hesitant to erase the drawing, I will erase this. There. Okay, and as always, remember when you have a nice long math lesson, it's hard to keep thinking if you're sitting still for too long, so remember to stop and stretch. Drawing things on a chalkboard wall is a really good way of stretching at least one of your arms. And don't be shy to take a little sip of your fizzy water when you need it. Well, for me it's fizzy. This is coconut. Okay, so reflection. I have to get off the translation page to the reflection page I have in my notes. Now I know at least some of the students who are watching this have the same notes. Well, it's actually a homework pack, but it looks weird, my version of it, because I print it so that each page has 4 pages printed on it, so it's very small, but I can still see it well enough, and that's useful for me while I'm doing my lesson plans and my lessons. So reflections. Really, the only reflections we're responsible for right now are when we reflect across 4 possible lines. And I'll use my yardstick to show where the lines are so I don't have to draw too much on this. One of the lines, of course, is the x-axis, which is very easy to find in our grid. And reflecting across it is easy to visualize. Another one is the y-axis. Same thing, very easy to visualize. In fact, that might be the one that looks most like a mirror. A reflection is what you see when you look in the mirror. And it feels like a mirror when you think, there's my mirror, I'm going to have a mirror image, which is going to land over here. And then the other 2 lines are x equals y, sorry, I said it backwards, y equals x, which is this line, which will make a 45-degree angle with both the x-axis and the y-axis. So reflecting across that line, that's something we will be responsible for doing. And then y equals negative x, which is, let me take a look at this. Yes, y equals negative x does the same thing, except it's tilted downwards instead of upwards. So we're reflecting across those 4 lines. And that's all of the examples we're going to talk about, at least for now. So what happens to the x's and y's? Because there's so few things that can happen, you can sort of find all of them and even memorize them if you want. So if we're reflecting over the x-axis, what happens is, let me see, I want to do it with notation. Reflect over x-axis. That makes xy become x negative y. And when you think about it with examples, it makes sense. Reflecting over the x-axis, if I reflected this triangle, well, my reflection isn't moving to the left or the right. So the x is staying the same. But all the y coordinates are going to become negative, or the opposite sign. Because we could start with one on the bottom, and if we reflect it over the x-axis, let's say we're reflecting my hand, If we reflect that over the x-axis, we'll get a mirror image that'll look kind of like this. Not exactly though. And the x won't change because it's not going to move to the left or the right. It's going to, it's hard to do that reflection with your arm. It's not going to move to the left or the right, so the x stays the same. But all the y coordinates of my hand right now would be negative because they're below the x-axis right now. But the reflection would be above the x-axis, so all the y coordinates would be positive, meaning the opposite sign. The way to show that in math is to say negative y, meaning if y was a positive coordinate, it will become negative. But if y was a negative coordinate to start with, it will become a positive coordinate. It's kind of cool. This is interesting to just think about. If we reflect over the y-axis, which takes way longer to write than it does to say, what's going to happen is x, y are going to become negative x, y, and the opposite thing happen. Now we're talking, oops, knocked something down. Okay, now we're talking about reflecting over the y-axis. The thing I knocked down was this ruler, I may as well show it. Reflecting across this is going to make the x's change, but it's not making the y's change. So the copy will not go up or down, it'll just move, well in this case, to the right. But if it started on the right and you reflected over the y-axis, it'll move to the left. So we have this math way of saying that. The x of the copy will be the opposite sign from the x you started with, but the y will not change. It'll be the same sign and the same size. So those are two of the four things that can happen. We may as well do all four, although I'm going to end up writing down low and get messy handwriting. That happens. Okay, reflect over y equals x. That's this one, remember. The diagonal line that forms a 45-degree angle with both axes that is tilted upwards as you look at it from left to right. So what's happening if I reflect something like this over that? It's going to go over here, isn't it? So the x's are going to change signs, but so are the y's. Is that what's going to happen? Let's check my notes. Reflecting over y equals x. That's what happens, is the x and the y change places. So you have x, y becomes y, x. And you'll see that is what happens. It's a little weird to look at, but when you experiment with it, you see that it happens. The students need to experiment by doing a lot of these examples. Finally, I'm doing, and it is getting messier and messier, my handwriting, reflect over y equals negative x. And when we reflect over y equals negative x, where'd it go? Reflect over y equals, there it is. The x and the y change places again like this, but they also change signs. So you have x, y, arrow, negative y, negative x. Try it. Look at these while you're doing some of the drawings. I don't have time to do very many drawings, but do some drawings and look at these and see how it makes sense. And if you really wanted to, the student could memorize all four of these, because for now these are all the only reflection situations that can happen. So we could memorize all four. But I don't know if I think that's the best way to learn anything, by memorizing it, because you can memorize something without understanding it. I think looking at these while looking at your drawings, that's where you get that understanding. That's what I recommend we do. Okay, next thing to talk about with reflection. I've done that. I think I'm done with that style of question. I think I need to do a reflection. And without this becoming too messy, the easiest reflection for me to do is to reflect ABC. So we'll just leave this there. That's my answer to my translation. But we will reflect ABC across the x-axis. Why not? So what's going to happen is vertex C, I'm starting with C. Why am I starting with C? That's interesting. I'm starting with C because it's closest to my mirror line. And I like that, my line of reflection. So it's easiest to see what I'm doing. C is 2 units above that line of reflection. So the reflection of C over the x-axis is going to be 2 units below. So I'll put a dot there. And that's where my C prime is. And I shouldn't call it C prime because that was my A prime, B prime, C prime. So I think I think I'm just going to pretend I never did this. So yes, I will say that's where C prime would be. It's less complicated than the other things I'm trying to think of doing. So here's where B is, and it's going to reflect as well. B is 5 units above that x-axis, so the copy of B is going to be 5 units below. Notice how I'm just putting the vertices, and I can't have a crooked, weird drawing because I'm not trying to draw the whole thing yet. This is my strategy. So that was B being reflected, so that's giving me B prime. And now A is also 5 units above the x-axis, so its mirror image is going to be 5 units below. It's going to be right here, and I'll label it. There's my A prime, and then I connect the dots. Even without a rule, oh, I made a mistake. I put the A prime one unit too far, confusing myself. But interesting, I may as well let the mistake become part of the lesson. Interestingly, when you make a mistake, when you have this strategy for your drawing, it's easy to see the mistake. It's easy to figure out what you did wrong. It's easy to fix it. So there's my A prime. Erase this other A prime that I put 1 unit too low. See how quickly this set of grid lines is becoming messy. Now I'm connecting the dots. Connect, connect, connect. And you can see just by eye that that is a pretty good mirror image of ABC. So the strategy of working with the vertices really helps. And this has gotten messy enough that I just want to erase it. I don't want to do anything else with this beautiful chalkboard wall graph paper. And I'm also looking at the time and figuring out how I can fit the rest of my lesson plan in. Well, one thing is for sure, for the rest of this lesson, the grid isn't going to slow me down anymore. Goodbye, grid. I love you, but goodbye. I've experimented with all sorts of ways in my head of how I could do this using the chalkboard, because the reason I use the chalkboard for a lesson like this, I could just put a piece of paper below the camera and you just see my hands in there, and it's a great way of teaching. It's just that I know a lot of students really like the chalkboard. So I try to keep the chalkboard in my lessons as much as I can. There's the meter stick falling down again. Okay, enough with reflection. Now the other two transformations are rotation and dilation, and I do intend to cover them, but I'm going to cover them a little differently without the grid, and I'm going to do it later. Instead of moving straight on to those, I am going to move on to do a bit of a review of last week. One of the things that I did last week, that I was showing last week, that I really enjoyed was the technique of constructing a parallel line through a given point. So to do that, you have to have a line on your page to start with. That's the line you're going to draw another line parallel to. So I'm going to do that. Now, I did 2 examples last week. I didn't think it was enough. So that's one of the reasons I wanted to do more of this week. I'm going to do 3 more times this technique, but I wanted to do it in a kind of a creative way. So what I'm doing is I'm just going to draw a triangle, a sort of a random triangle. I'm not trying to plan it too much. And this. There. Should I label the vertices? I don't think I really need to label the vertices. You can kind of do it or not do it. I don't know. I have mixed feelings. Now, when we did this technique, drawing a parallel line, we needed a dot. There had to be a dot, a point to draw the parallel line through. So I'm going to place dots on all 3 sides, and I'm going to do it 3 times. So basically I'm doing this thing, but I'm using a triangle as my starting lines, just because I thought it would be cool to do that. So for this one, I'm going to put the dot here. I'm not trying to make the dots the same distance from the line. That one's fairly close, but this one's going to be, I'll make it further. And then this one, maybe I'll make it even further. Now we'll see if I can even manage to fit this whole drawing on here. No, it's not going to be easy to do that. I don't want to mess up my title. So I'm moving this one much closer. And I'm even going to move this one closer. There. Hoping that but this one's quite far. All right, good enough. All right, let's get going with our technique. Now, constructing a parallel line. the first thing I do is I draw a line from the vertex of my starting line. So I'm going to start with this one, and I draw a line right through the point from there. So let's do that. Hopefully I don't mess this up. It's the first time I've ever tried doing it, so it's a bit of an experiment. Let's draw the line. I'm drawing it longer than I think I need, which is usually my strategy. Then I'm drawing arcs. I need my compass. Okay, I have a bit of chalk in here, hopefully enough. So I'm drawing an arc. In here, in between my vertex and that dot. And then I draw another arc, moving the point of the compass to the dot, and I draw another arc, and I draw it longer than I think I need on purpose. So I think that turned out pretty good. Then I use a compass to measure. I use the compass to measure the arc. So this is not, I had to keep these the same distance apart while I drew those two arcs, but now I can change it. And what I'm doing is I'm using the compass to measure this arc, and I did a pretty good job. And then now that I have it measured, I don't want to change it. I want to move over here to where the second arc went through this line, and I want to draw another arc without changing the size that's being measured by the compass. I did it. Now, have I got to the end? I think I pretty much got the end. It's confusing because of all the extra stuff. So what I need to do is I'm going to draw a line longer than I think I need through the dot and where these two arcs meet. Even make it nice and long. I'll go as far as I get to my geometry label up here, and I'll make this one longer as well. Yeah. I did it because I believe that this line is parallel. I'm doing that thing that I was showing last week where look at it from this. Yes, it does look like it's nicely parallel. So it worked. The instructions work. So now I'm going to do it again. I'm going to do it with this one. Now this is going to be weird because it's below. So I'm using this vertex, and I'm drawing a line from that vertex through the dot, longer than I think I need. Now I need my compass, so this should go faster and faster as I find myself practicing. That's what happens. So I want to choose somewhere that's in between the dot and the line, not too close to either, and I want to draw an arc. And then I go over here and I draw the same arc without changing the size that's being measured out by the compass. I'm really getting quite low on chalk in this thing. That's what it's jammed in there too. So I'm just going to have to hope that it lasts. Okay, next I measure that first arc. And this is too long, I have to squish it down a bit. Measure the arc, it's still too long, a little smaller. And now it's good. And then I go here and I draw another arc. Hard to do when the chalk is too short. And now I'm drawing a line. Okay, from the point through the spot where the two arcs meet, make it nice and long, nice and long, nice and long. Pretty good, and it does look parallel. It looks quite good to me. Doing it again third time. How do I do this? I'm going to use this vertex. Draw the line from the vertex through the dot, longer than I need. Compass time. Now this is quite close, so I have to make a pretty small measure here to draw the arc. And I'm drawing this arc. Hard to do. There. And then I go over here and I draw the same arc without changing the size measured out by the compass. And now I measure the arc, the first arc, which means I'm squishing down this compass quite a bit, and I go here, and I draw another arc, so the 2 arcs across. Nearly finished. Finally, I get my ruler, and I draw the line. Oh, I made a mess. I didn't do it very well. That arc isn't good at all. These 2 arcs aren't good at all. I'm going to start that part over. I was hoping this would go so much better. I thought it was going to go beautifully. It seemed to be going so well. Let's go back to the compass part. Okay, so from the line down to the triangle that I started with. And then I go over to the dot, and I do it again. So I don't know how I managed to do that so crooked. Doesn't look too bad now. Then I measure the arc, and then I go here, and I draw another arc that crosses. I think it looks better this time. Well, I'm not going to say that's the best I've ever done this, but it's pretty good. And what we managed to do by doing this technique 3 times, besides practicing it a lot, which has to be a good thing to do, is we drew a great big triangle, and all 3 sides of the great big triangle are parallel to the 3 sides of the triangle we started with, except where it looks a slightly bit crooked because I didn't do it that well. And what that means is if I had done it perfectly, this big giant triangle would have to be similar to the smaller one because it would have the same angles. And I'm not going to measure the angles because I wanted to, but it's just that I don't have enough time. Okay, that's an interesting little experiment. And I am glad I did it. I would have liked it if the drawing had been a little more perfect. But I'm kind of happy. And I will play my excuse card, the teacher's excuse card. It's hard to do this on a chalkboard, you know. Okay, I played that card. Not going to try to play that card again. Hopefully, not again in this lesson. How much time do we have left? The next topic I want to do has to do with drawing triangles. Now, we just drew a triangle, but we weren't really following instructions for drawing a triangle, were we? We were following instructions for drawing parallel lines. And it was interesting how we could use that set of instructions and end up drawing a triangle. But now I'm going to do another type of drawing a triangle exercise. You can be asked to draw a triangle where you're given some of the information about that triangle, about angles and lines, the lengths of the sides, etc. And there are all sorts of ways that these instructions can be given, and I've always found this a lot of fun. Where are my examples? Here. I have my examples here. So there's various ways of asking these questions. I'm going to try a bunch of different ways. I have enough time, I think I should be able to do this. So draw a triangle. I'm going to write draw a triangle once and hopefully not erase it. And remember not to erase it and just keep on erasing the instructions that you're using to draw the triangle. So this time with sides of 7 inches, 8 inches, and 9 inches. Is that what I chose? No, I chose 7 inches, 8 inches, and 10 inches. Okay. So this is one way you can be asked to draw a triangle. Now, how do you draw a triangle when you know all 3 side lengths? Well, that's kind of easy, drawing side lengths that size, but how do you get the angles right? And that's part of the fun, is realizing which tools will work for a different situation depending on what information you've been given. Now, obviously, whenever you're drawing a triangle, I can expect usually the first step would be to draw one of the sides. If you can, if you have information, but I know all 3 side lengths. So what I'm going to do is I'm going to start with the longest one, the 10-inch side. Now 10 inches is a very big triangle for me, but on the in the video on a chalkboard, it might not actually look that big. So let's draw a 10-inch line. That's going to be there. This is 10 inches. So yes, on the video it does look kind of small. And I feel like labeling this triangle ABC, so I'm going to call these vertices A and B. Okay, now I have to draw a 7-inch line and an 8-inch line, and that would be easy to do, except that I don't really know where to draw them. And I don't want to just do it with trial and error. I want to have a method, and I can think of a method. The method involves using both the ruler and the compass. I'll get it set up in here, and then I'll try and show you. So what I'm doing is I'm taking the 2 points of the compass and I'm putting one of them at 0 on my ruler, and I need a side 8 inches long. I'll do that one next. So I'm getting the other end of the compass to be 8 inches. And that's pretty good. I think I've done that. So these are now 8 inches apart. So, and I can do this. I have so much flexibility because I could have done the 7-inch instead of the 8-inch. I could have started with the 7-inch line instead of the 10. I have all sorts of flexibility. And now I have more flexibility because I want to draw an arc. But should I draw it from A or from B? Doesn't matter. These instructions are flexible. I'm choosing to draw the arc from B. And I'm going to draw an arc, which I know is 8 inches from B. That's the size that I did. Now I'm going to do the 7-inch. I forgot to show it to you, so I'll show it to you now that I'm doing the 7-inch. Obviously, I'm going to have to switch this down a bit. So let's try and do that just by eye. I get the pointy thing at one end of the compass at 0 on the ruler, and I get the other end to go to 7, and in fact I got kind of lucky. And it's kind of there. I don't know if I'm going to be able to show this at all. I don't know if it shows up in the video at all, so you might have to trust me. It looks like the ruler is full of glare to me. So these are now 7 inches apart. I go to the other vertex. I can't use it B anymore now. Go to the other vertex, A, and I draw an arc. And where the two arcs cross has to be 7 inches from A and 8 inches from B. When you think about how arcs work, it makes sense. So all that's left now is to draw the last two lines. From the point where the arcs cross, I'll draw a line that connects to A. From the point where the arcs cross, I'm drawing a line that connects to B. And I have, and I'll call this C, why not? And I have a triangle that obeys the instructions, and then I can test it. I can measure, because I never actually drew these with them measuring. So now I can measure them after the fact. Where's my, there's 0, yes, that is 8 inches. And this one, yes, that is 7 inches, it works. So whenever you get all three sides, if you know how to use your compass, you have a method to be able to draw a triangle, and it's kind of cool. The method's cool. Where the two arcs cross is the point that you need. And if you didn't know this method, well, how would you do it? It would have to be trial and error, and that's not the best way to do things. Having a method that you know will always work for this type of question is the best way. I'm going to erase everything except the draw a triangle part, and I'm going to do my next type of draw a triangle question while sneaking a look at the time. Draw a triangle with a 90-degree angle between sides of, I chose 4 and 3 when I was doing it on paper before, but no, I want something bigger than that, bigger than the 10 we used before. Between sides of, how about 12 inches and 18 inches. Let's see if I can do that. I'm sort of making up the numbers at random, and that can be a dangerous thing to do at times. I need a 90-degree angle. And between these two sides. So how do I draw a 90-degree angle? Now, of course, we use a protractor to draw angles, but we haven't really done that yet. I was kind of saving all the protractor stuff for next week and the week after. But yeah, we saw the protractor last week. We know that the protractor's there, and we can use it if we really want to. So I could use my protractor to draw a 90-degree angle. And I'm jumping ahead into some of next week's skills, sure. But I can also do that thing where I know that this piece of paper is a rectangle. I don't want to show you all of the notes from my other lesson, but it's on both sides anyway. Okay. We know that these are 4 90-degree angles because the paper is rectangular, so I'm not going to use the protractor. What I'm going to do is I'm going to just trace around the corner enough so that when I remove that, that smudge has a 90-degree angle in it, And I'm just going to start drawing the lines. So, I know that the two sides I need on either side of this, I can even put that little square that shows it's a 90-degree angle, I can put that in right away. I know the two sides are 12-inch and 18-inch, so I'm going to draw the 12-inch one here. Let's get the inches side of my ruler. 12 inches. Going up right where that little smudge is nice and clean and it shows where my 90 is. 12 inches exactly. And then I'm going 18 inches over here. This will be a little easier. 18 inches there. So I know that this is 12 inches. And I know this is 18 inches. And I know that's a 90-degree angle, and I can even erase all the little smudges if I want, but I don't necessarily really want to. I think it looks kind of cool. And then what do I have to do? I have to connect the dots. I keep on having these strategies that end with me connecting dots. Connecting dots meaning connecting the vertices. Because the vertices for the last side of the triangle, which will be a hypotenuse because this is now a right triangle, those vertices are going to be 18 inches from here, and 12 inches from there. It works. I can test it, but I already know that's 12. I know that's 18. The only thing to test would be to measure the 90 with a protractor. And, oh, okay, let's do it. Yeah, that's 90. See the 90 there? Yeah, that's 90. Okay, I still want to save the protractor for next week as much as possible. Next set of instructions for drawing a triangle. This is fun because there are so many different ways to tell the student to draw a triangle, but give them different information, so the techniques keep on being different. There's only a few techniques that you need, but they're all cool. So I'm going to erase all that and my beautiful triangle. And where did I put the piece of paper with the triangle? And there it is. I'm getting to be a little dry mouth. There's not that much time left in the lesson, about 13 minutes. So it's time for a fizzy water, the coconut, pineapple coconut fizzy water. Okay. And someone who I won't even look at because I don't want to jinx it is being very well behaved over on the armchair over there. Okay. Looking at this next one and thinking about it, I'm going to have to use the protractor for this. A 12-inch side between angles of 30 degrees and 60 degrees. Okay, so I need a 12-inch side, so it's kind of an easy starting point. That happens a lot, where you start by just drawing a line. You know how long you need to make it. 12-inch side. There it is. And I'll even label it as being 12 inches long. Now, 30 degrees and 60 degrees, I need a protractor. This one I need a protractor, so I'm not going to try to shy away from using the protractor, which means I'm giving a little bit of a prequel to next week's and the week after's lessons, which are going to be more heavy on the protractor. So I'm going to one of the vertices, whichever one I want, and making the zero dot on the protractor go right where the vertex is, making sure that the baseline of the protractor goes on the line that I'm starting with. I need a 30-degree angle, so I'm using these two sets of numbers. I'm using the inner set of numbers because I'm on the right side of the protractor and counting up to 30, and then I'm just putting a little line, a little mark, because I don't know how long to make this line. So what I do is I take the ruler or any straight edge and I make the line longer than I need. I think that should be longer than I need. This is where that little mark was, but we don't necessarily have to know where that mark was anymore. And then the other angle is 60, so that means I'm going over to the other side, to the other vertex that I haven't used yet from the original line. I'm doing the same thing, sort of. Baseline is on the line, zero dot of the protractor is on that vertex. This time I'm on the outer set of numbers because I'm on the left side of the protractor, And again, I make a mark. Now, why don't I just put the dot exactly where I need it, because the protractor's in the way. So I make a mark that I know is 60 degrees from that vertex. And then the straight edge allows me to connect that mark to the vertex, and I have created the triangle I wanted. And this should be 30-degree angle, and this should be a 60-degree angle. And we can check if we want, but why should we check? We drew them. So there's nothing much for me to check. I can figure out what the last angle is, or I can measure it, or there's all sorts of things I can do. And what about these? The way I made the lines too long, what about that? Should I erase? Should I be carefully erasing? No, I don't have to. Because those are called construction lines. And what they're doing is they're showing anyone who looks at the triangle afterwards how I made it. So if it was, say, a test question, and I asked a student to do this, I want the student to leave their construction lines, because if the student made a mistake, like reading the wrong number on the protractor or something, the construction lines show me the technique they're using. And I'm able to see that this student actually does understand what they're doing. And this, when you're evaluating students, that's what you're looking for. You're not just looking for a mistake so you can give a 0 and you'd be happy about being mean to students. That's not what we want to do. What we want is to make sure the student understands the techniques that they're supposed to be understanding. Construction lines help to do that. One thing, though, that I could say is it might help when I draw the lines. I kind of forgot to do this. I didn't have to draw solid lines. I could have drawn dotted lines. So if I have enough time to do another example like this, I'll try to remember to do dotted lines. And then what you do is you make dotted lines which are not necessarily part of your answer. That's what dotted lines are telling the person. But then you fill in the part that really is a side of the triangle, make that solid. So that would be even better. It's kind of what this looks like now that I've put smudges with my fingers. But I don't want to dwell on that anymore. I want to do another one because I know I have other sets of instructions that I can do. Okay, here's a good one. I really want to do this one. It might take up all the rest of the time, so there's things I was thinking of doing that I might not be able to do. But I really like this example because I'm going to answer this question twice. And I love those. When you answer a question twice and show two different ways that work, and you compare the two things and think about why they both work, and it makes you learn. It's more than just memorizing steps. It makes you think about what you're doing. So, some erasing needs to be done. I will erase this beautiful triangle and all of these instructions, but I'm still keeping the draw a triangle part. No, I have to change it. There's something different. So I'm going to keep the draw a part, and I'm going to turn a into an. Draw an isosceles triangle. And we should know that isosceles triangles have two angles that are the same and two sides that are the same. I think students might already know that, but I'm not actually that sure, so I'll say it. Draw an isosceles triangle. With one 10-inch side. It didn't say it's the only 10-inch side. One 10-inch side. So we have three sides in a triangle. We know one of them has to be 10 inches to do this one correctly. And an apex angle of 38 degrees. And an apex angle of 38 degrees. Apex angle matters in isosceles because there are three angles in the triangle, and isosceles triangle, two of them are the same size as each other. The third one, the one that's not necessarily the same size as either of the other two, is the one that we call the apex angle. So you'd think this is very specific. Let's see now. How am I going to do this? I'm going to start by drawing a 10-inch side. This is usually the starting point with most of my triangles. There, that's 10 inches. Okay, now I can draw a 38-degree angle, because I need one, and I could do it on either side. So this is one thing that I could try doing, right? I'm going to set up my protractor. 38, there I am using the protractor yet again. 38 degrees, inner numbers, so that's here, that's going to be right around there. Not sure how long to make this side, or am I? So I can say, well, let's make that second 10-inch side, because two of the sides have to be the same length. So I'm going to make this 10 inches long. Set up my ruler, make sure it goes through the vertex and that little mark, and then draw a 10-inch line. So this is also 10 inches. And this is 38 degrees, we know that. So label it, and then I can connect the dots to finish my triangle. Well, I did it. This is isosceles. Two 10-inch sides. These two angles have to be equal to each other if I successfully made it isosceles. So let's measure them and test it. I have to measure two. I'll do this one first. So baseline, 0 dot. Starting from 0 means the inner numbers. I'm going over here and I'm seeing that looks like it's about 72 degrees. So I'll just put a little arrow and say, I think it's 72 degrees. Now I'm going to do this one. Okay, baseline, 0 dot. Oh, wow, 72, yes, 72, they're both 72 degrees. Now, they might be a little off because of drawing error, measurement error. So I'm not sure right now, are they 71, are they 73? They're close to 72. Is that 38 really, or did I make it a little too small or a little too big by accident? I'm not sure. But there is something that I can do here, which is I know there's a fact that the three internal angles in any triangle are supposed to add up to 180. So what happens if we add 72 plus 72 plus 38? 8, 10, 12, I have a 2, carry the 1, 14, 17, I have 182 degrees. So it isn't exactly 180, but it's so close that I know that the difference is because of measurement error or possibly drawing error. And I'm playing this is hard to do on a chalkboard card again. I'll leave all of that there. Now, that means I don't have very much room though, because I want to do this again. What if I start with a line and I'm just going to make the line longer than I need on purpose? I do that a lot. So I'm going to make a line way long. And what if I draw a 38-degree angle from this vertex at the end of that line? 0 dot, baseline, inner numbers, because I'm on the right side of my protractor. Well, from where my eyes are, you can see it's on the right. So 38 degrees is going to be about there. And that means I can use a straight edge to connect the vertex and that little mark I made. And again, I'll make the line longer than I need, which I can just do this. Make it longer than I need. It's a little sloppy, but I do know that this is a 38-degree angle. That's interesting. But what if instead of trying to make these both 10 inches long, what if I try to make the third side 10 inches long? I'm going to try that. I'm going to get, how do I do this? Oh, I know what to do. I'm going to use my compass. Yes, that's what I want to do. So I want to find 10 inches with a compass. So I'm going to get this up against my ruler. Where's the 0? And again, I'm not going to try and show the camera, it's too clumsy, and I am running out of time, so this is the last thing I'm doing in this lesson. 10 inches, there. That's 10 inches. Pretty close to 10 inches, as well as I can do with this. And now, from here, I'm going to draw an arc. Now, both places where the arc crosses those two lines have to be 10 inches away from that vertex. I'll call it A. Never bothered to name this triangle. So these are both 10-inch distances from here to here, and from here to here. So the problem is that's an arc. So it's not really a triangle yet. What I need is to get a straight edge and connect these B and C with a straight line. And this should be 10 inches long because of the way I chose to do it. So let's make sure. Nope. Oh, I accidentally did this kind again, and I don't have enough time to redo it the way I intended to. Well, anyway, so I did manage to draw this triangle with slightly different strategies. And I still think that's kind of cool. I just have to think about what I should do besides drawing an arc the way I did to make sure that I have the 10 inch, that this is 10, because this is not 10 inches. I'm erasing that. That's actually going to be the same length as this one. I just accidentally did this the same way twice. Okay, well, fortunately, all these techniques still work. And geometry is still cool, and Mocha's still here, and she's very well behaved, so I'm going to give her a chance to say goodbye, because for her it is supper time, and that's all she can think about right now. So my Liverpool shirt and my big piles of powdery snow outside the window, and my cute dog and me are very happy to have taught you math yet again, and we look forward to the next time we get to do it, which will be soon. Goodbye.